Good evening. Is it audible? Hello, is it audible? Good evening to all. Is it audible? Good evening to all. This is Juhibis from Goscore Learning Center. We are the fastest growing ETA company in GCC. Our main aim is to provide education to all. I hope everyone is doing well, is it? So in part 1 video, we discussed about the general introduction of amines. This is general introduction of amine and the method of preparation of amine and then physical property. So in this section, we are discussing about the chemical reactions of amine. We can look which are the chemical reactions of amine. The first one is basic character of amine. The next one is alkylation that we already discussed. Then the third one is acylation, and the fourth one is carbyl amine reaction, and the next one is reaction with nitrous acid, and the next one is reaction with aryl sulfonyl chloride, and the last one is electrophilic substitution reaction. Okay, first one is basic character of amines. You know that amines is being basic in nature, is it? What will happen when amines react with an acid? What will happen when a base react with acid? You are studying from your ninth standard itself that a base react with acid, form salt and water. Here, amine, that is RNH2. Suppose you are treating with HCl, what will you get? Using the lone pair of nitrogen, it will accept the hydrogen and it will form salt, that is RNH3 plus Cl minus. So this is called aniline chloride. This is again a board exam question that what is write the major product when aniline react with HCl. You will get aniline chloride will be obtained. Aniline chloride will be obtained. So amines being basic in nature, it react with acid to form salt. See, what is primary amine? Secondary amine, tertiary amine. What's the general formula of that one? That is RNH2 is primary amine. Is it RNH? R is secondary amine. RNR is the tertiary amine. Is it? How will you determine whether the compound is primary or secondary amine? Depending on the number of hydrogen atom present on the nitrogen. RNH. Is it? So here the basic character of amine can be explained in terms of Kb value and pKb value. What is Kb and pKb? So in your 11th standard, suppose if you are reacting primary amine with water, it will dissociate and to form RNH3 plus OH minus. So you all studied in your 11th standard equilibrium constant. How will you find the equilibrium constant? Kc is equal to concentration of the product R NH3 plus concentration of OH minus divided by concentration of the reactant, that is RNH2, into concentration of H2O. See, H2O is a constant. So a constant into constant, you will get another constant, that is Kb, basicity constant. Kb is equal to concentration of RNH3 into concentration of OH minus divided by concentration of RNH2. So what is pKb? pKb is equal to negative log of Kb. Negative log of Kb. From this, you can understand that larger the value of Kb or smaller the value of pKb, stronger is the base. That is, Kb is directly proportional to basicity, and pKb is inversely proportional to basicity. Is it clear? So remember, larger the value of Kb or smaller the value of pKb, stronger is the base. Okay. Then if you compare, what is the basicity order of gaseous phase? If you compare primary amine, tertiary amine, secondary amine, so this is secondary amine and this is tertiary amine. So you can see an alkyl group here. What is an alkyl group? Alkyl group is an electron releasing group. So it will donate electron to nitrogen. So on primary amine there is only one alkyl group. For secondary amine there is two alkyl groups. So from this side and from this side the electron is donating. For tertiary amine it is for tertiary amine the three groups are alkyl groups. So from the three side electron is giving. So the electron density will be more on nitrogen. So the basicity order in gaseous phase is tertiary greater than secondary greater than primary. What is the basicity order for gaseous phase? Tertiary greater than secondary greater than primary. But when you compare in aqueous medium, this is not in the case of aqueous medium. Why the order is changing in aqueous media? See, in aqueous media, the basicity order is determined by the stability of conjugate acid. The stability of conjugate acid is depend on three factors. First factor is inductive effect. That is plus I effect. Second factor is steric hindrance, and the third factor is hydrogen bonding. So the plus I effect, we already see that the order will be tertiary greater than secondary greater than primary. Is it? For this is primary amine. This is secondary amine. And the last one is tertiary amine. So steric hindrance, here there is only one alkyl group. Is it? So proton can attach to it easily. But here there are two alkyl groups. It hindered the attack. Here there are three alkyl groups. So the order will be primary greater than secondary greater than tertiary. Then on comparing these three, hydrogen bonding is more on primary. Is it? So then the secondary amine there is only one hydrogen. For tertiary amine there is no hydrogen. So the order will be primary greater than secondary greater than tertiary. On comparing on the basis of these three factors, we can see that secondary amine is common in three of these cases. Scientifically, it is proved that secondary amine is more basic. So the order for methyl substituted amine and ethyl substituted amine is different. For methyl substituted amine, for methyl substituted amine, for methyl substituted amine, the order will be secondary greater than primary greater than tertiary greater than then ammonia. For ethyl substituted amine, the order will be ethyl substituted amine. The order will be secondary, then tertiary, then primary, then ammonia. Okay, you have to study the order, this order. This is in the case of aqueous medium. Okay, is it clear? Then alkylamine versus ammonia. Which one is more basic? Alkylamine or ammonia? This is again a board question. Which one is more basic? Alkylamine or ammonia? Which one is R alkylamine? This is RNH2 and the structure of ammonia is here there is one alkyl group. Electron releasing alkyl group is there. Due to plus I effect, this alkyl amine is more basic, stronger base than ammonia. In ammonia, there is no alkyl group, there is no electron releasing group. So alkylamine is more basic. Next one is arylamine versus aliphatic amine. Arylamine means benzene ring containing NH2 group. This is called benzamide or aniline. This is, suppose we can take methanamide. Methanamide. Okay. On compare these two, which one is more basic? See here, this lone pair of electron will be on conjugation with the benzene ring to form resonance structure. Here, here there is alkyl group. Due to plus I effect, electron will be releasing to the nitrogen. So the protonation will be more easily. Here less protonation is available. So this is, sorry, this is more alkylamine is more basic than arylamine. Okay, is it clear? Then the next one is arrange the following in the decreasing order of their basic strength. So you know the order for the order will be aliphatic amine is more basic than ammonia, then aromatic amine. So this will come first. This is aniline on the decreasing order. So the highest will be secondary amine, that is C2H5 NH greater than C2H5 NH2 ethanamine, then ammonia, then C6H5 NH2. So this is the order, this is the decreasing order of their basic strength. Secondary amine have higher, then primary, then ammonia, then aromatic amine. Is it clear? The next one is acylation. Tell me which is the acyl group. You already studied about what is acyl group, what is acetic anhydride. Tell me what is acyl chloride. What is the general formula? Acyl chloride. General formula of acyl chloride is RC double bond O Cl is called acyl chloride. Amine on reacting with acyl chloride, you will get amide. The product will be amide. Okay. CH3 NH2 plus plus CH3 C double bond O Cl. Just eliminate one H and this Cl. Eliminate HCl. In the presence of base, you will get CH3 NH C double bond O CH3. You will get N either. See, this is a secondary amine, is it? There is only one hydrogen. So, N-methyl ethanamide will be obtained. N-methyl ethanamide will be obtained. Just eliminate the HCl. Okay. Next example is that CH3, CH2, NH2. On reacting with C6H5COCl. What is C6H5COCl? It is benzoyl chloride. Amine on reacting with benzoyl chloride is called benzoylation. That is known as benzoylation. In the presence of base, remove the HCl, you will get amide. That is CH3, CH2, NH, CO, CH3. C6, H. You will get N-ethyl benzamide will be obtained. Next one, what is acid chloride? What is the general formula of acid chloride? RC double bond O, O, C double bond O, CH3 is acetic anhydride. What is acid chloride? RC double bond O Cl. What is acetic anhydride? RC double bond O, O, C double bond O, R. General formula of acetic anhydride. Okay. CH3 NH2. What is this? What is the IUPAC name of this one? Methanamide. This methanamide on treating with acetic anhydride, that is CH3 C double bond O, O, C double bond O, CH3. remove one hydrogen and it will be eliminated as acetic acid CH3COO, one hydrogen from here, so it will be eliminated as acetic acid and the remaining will be CH3NHCOCH3 plus CH3COH. Why we are adding this base here? See, here HCl and here CH3COH, both are acid. To neutralize that acid, we are adding this base. Okay. So this is all about acylation. The next one is carbylamine reaction. See, carbylamine reaction, these are the distinguishing tests of amine. These are the distinguishing tests of amine. This is very, very important. Okay. Here we are doing, here you are given to you a compound is given. You have to identify that the compound containing amine or not. Okay. So first we are doing the test carbylamine reaction. In this reaction, we are doing primary aromatic amine or aliphatic amine. Maybe we don't know which amine is that. We have to find that one. So amine on treating with chloroform in presence of KOH. On heating, you will get a foul smelling substance. That foul smelling substance is called isocyanate. From that, we can understand that the compound contains an amine. Secondary and tertiary amine do not answer this reaction. So this test is also called isocyanate test. So the equation is RNH2. RNH2 on reacting with chloroform. What is the general formula of chloroform? CHCl3 is the general formula of chloroform in presence of a base, that is KOH. On heating, you will get RN, you will get RNC. What is RNC? Isocyanate, the foul smelling substance, which is a foul smelling substance that formed in carbylamine reaction, isocyanate, plus 3KCl plus 3H2O. So from the first distinguishing test, we understand that the compound containing amine. Now we have to find that it may be primary aliphatic amine or primary aromatic amine. The next test is to distinguish whether the compound is primary aliphatic amine or aromatic amine. That is reaction with nitrous acid. Reaction with nitrous acid. Then tell me what is nitrous acid. NaNO2 plus HCl is nitrous acid. See, RNH2, primary aliphatic amine, react with nitrous acid NaHNO2 in presence of NaNO2 plus HCl. You will get aliphatic diazonium chloride will be obtained. That is Rn2 plus X minus. You will get aliphatic diazonium chloride will be obtained. This is unstable. This is unstable. This on treating with water, you will get alcohol. Along with that, nitrogen gas is liberated, HCl. So, if you are, suppose this is a test tube, you are adding nitric acid to it, you can see nitrogen gas is evolved in the test tube. From that, you can confirm that that is aliphatic primary amine. If you are taking aromatic primary amine, that is, if you are taking aniline, aniline on reacting with nitrous acid, NaNO2 plus HCl in 273 to 278 Kelvin, you will get diazonium salt. Benzene diazonium salt will be obtained, that is stable due to resonance plus H2O. So here you can see the evolution of nitrogen gas. From that you can understand that is aliphatic primary amine. Here the compound is stable, so you didn't get any reactions here. So if it is nitrogen gas is evolved, you can say aliphatic primary amine. It is not. It is aromatic primary amine. So suppose if you are talking in the lab, you didn't see the evolution of nitrogen gas. How will you identify that compound is aliphatic primary amine or aromatic primary amine? We can do another test to confirm that the compound is aromatic primary amine. That is azo dye test. Here benzene diazonium, benzene diazonium chloride on reacting with, this is benzene diazonium chloride, is it? On reacting with phenol, on reacting with phenol, on reacting with phenol, this is phenol. So on the para position of the phenol, the hydrogen will be removed, and this group acts as an electrophile. This electrophile will be attached on the para position. This electrophile will be coupled at the para position. So you will get a para hydroxy azobenzene that have orange dye. From the color you can understand that the compound is aromatic primary amine. So this is para hydroxy azobenzene, double bond and para hydroxy azobenzene, that is orange dye. You will get orange precipitate. Okay. The next one is, if you are taking aniline instead of phenol, if you are taking aniline, say you will get para amino azobenzene. First we have to react benzene diazonium chloride, and from the para position hydrogen will be removed and the electrophile will be attached on the para position. Then you will get para amino. This is carried out in presence of acid. So you will get the azo group will be attached on the para position. NH2. So this is para amino azobenzene. That is yellow dye. Yellow dye will be obtained. From this, you can confirm that the compound is aromatic primary amine. First distinguishing test is carbylamine reaction. From the carbylamine reaction, we understand that the compound containing an amine or not. Next test is reaction with nitrous acid. Reaction with nitrous acid, if the nitrogen gas is evolved, we can say that the compound is primary aliphatic amine. If it is not, we can say primary aromatic amine. But you have to confirm that it is primary. You didn't see the effervescence of nitrogen gas. So you are done azo dye test. From that you can understand if it is orange dye. If you get orange dye, you can confirm that the compound is aromatic amine. Instead of you, if you are using aniline, you can say you will obtain para amino isobenzene, that is yellow precipitate. From that you can confirm that the compound is aromatic primary amine. Now I want to distinguish whether the compound containing primary, secondary, tertiary amine. The next test is for distinguishing primary, secondary, tertiary amine, that is reaction with aryl sulfonyl chloride. Reaction with aryl sulfonyl chloride, that is benzene sulfonyl chloride, that is C6H5SO2Cl. That is called Hinsberg reagent. What is that? Hinsberg reagent. Again, important question. What is Hinsberg reagent? C6H5SO2Cl. Hinsberg reagent react with primary and secondary amine to form sulfonamide. It will react with primary and secondary amine to form sulfonamide. If the benzene sulfonyl chloride, that is the structure is benzene sulfonyl chloride, on reacting with, this is benzene sulfonyl chloride, this on reacting with primary amine, we are taking ethanamide, so C2H5. From here the HCl will be removed, then you will get benzene S double bond O NH C2H5, that is N-ethyl benzene sulfonamide. N-ethyl benzene sulfonamide. See, here there is one hydrogen. Due to the presence of strong electron withdrawing group, this hydrogen acts as acidic. Acidic. So it is soluble in alkali. Soluble in alkali. The precipitate is soluble in alkali. Is it clear? Benzene sulfonyl chloride on reacting with primary amine, you will get N-ethyl benzene sulfonamide, that is soluble in alkali. If it is soluble in alkali, you can confirm that that is primary amine. If you are treating with secondary amine, if you are treating benzene sulfonyl chloride with secondary amine, that is C2H5, eliminate the HCl, then you will get S double bond O N C2H5 C2H5. That is, you will get N comma N diethyl, N comma N diethyl benzene sulfonamide will be obtained. Here there is no hydrogen, so it is insoluble in alkali. Insoluble in alkali. Insoluble in alkali. So tertiary amine do not undergo this reaction because there is no hydrogen. Is it? So from this we can distinguish it whether it is a primary, secondary or tertiary amine. I hope this is clear for you, the distinguishing test. First one is carbalamine. In carbalamine, the primary amine react with chloroform and KOH. You will get isocyanate, foul smelling substance. Which is a foul smelling substance that formed in carbalamine reaction? Isocyanate. Next one is reaction with nitrous acid. From the reaction with nitrous acid, we can confirm that the compound containing aliphatic amine or aromatic amine. If nitrogen gas is evolved, you can say that aliphatic amine it is. If it is not, aromatic amine. Aromatic amine, if we have to confirm that if it is aromatic amine, whether it is aromatic amine, we can do azo test, that is coupling reaction. Then, if you want to find whether the compound is primary, secondary, or tertiary, we can do Hinsberg reagent, the reaction with benzene sulfonyl chloride. Okay. The next one is electrophilic substitution reaction. See, amine is an ortho-para directing group. So, the incoming electrophile will be attached on the ortho-para position. If you are doing direct bromination, first one is electrophilic substitution can be done in three ways. Bromination, first one is bromination, second one is nitration, and third one is sulfonation. If you are doing direct bromination, that is aniline on treating with bromine in presence of bromine in water, you will get 246 tribromo 246 tribromo aniline will be obtained. Here the incoming electrophile will be attached on the orthopara position, that is 1 2 3 4 5 6, that is 2 comma second position there is Br, fourth position there is Br, and the sixth position there is Br. So it is 246 tribromo aniline will be obtained plus 3HBr. Is it clear? So this is on direct bromination. But I want mono substituted aniline. How can I prepare mono substituted aniline? By reactivating the power of NH2 group. How can I control the NH2 group? The activating power of NH2 group by adding protecting group. So here, first the aniline is treated with acetic anhydride. Here acetic anhydride is a protecting group, that is CH3CO twice O in presence of pyridine. In presence of pyridine. From here, one hydrogen will be eliminated as acid. See, right here, that is CH3 C double bond O C double bond O CH3. This is acetic anhydride. Is it? From here, one hydrogen will be eliminated and it will be eliminated as acid. The remaining will be C double bond or CH3. Is it? So it will be attached on the nitrogen. That is NHCOCH3. That is acetaldehyde will be formed. This on bromination, that is bromine in acetic acid, the bromine will be attached on the para position. The bromine will be attached on the para position Br. NHCOCH. That is, you will get para bromo acetanilide will be formed. This on hydrolysis, this group will be eliminated. COCH3 group will be eliminated, and then you will get NH2 Br, that is para bromo aniline will be obtained. Mono substituted aniline will be obtained. Para bromo aniline. So this is all about bromination. That is, if you are doing direct bromination, you will get 2,4,6 tribromo aniline will be obtained. If you are adding protecting group, then you will get para bromo aniline. The next one is nitration. So in nitration, see, same as that of bromination. In nitration, if you are doing direct nitration, you will get ortho meta position. There you will get a nitro compound. That is in presence of concentrated H2SO4 and HNO3. You will get para-nitroaniline NH2 plus meta-nitroaniline, then ortho-nitro, ortho-nitroaniline will be. So if you are doing direct nitration, you will get para-nitroaniline, meta-nitroaniline, ortho-nitroaniline. But I need only nitro group at the para position. Again, we have to add protecting group here, that is aniline on reacting with acetic anhydride in presence of base pyridine. You will get acetanilide NHCOCH3 acetanilide. This acetanilide on reacting with H2SO4 HNO3, you will get para-nitro acetanilide will be obtained. Para-nitro acetanilide will be obtained. This on hydrolysis, you will get para-nitro aniline will be obtained. Para-nitro aniline will be obtained. Is it clear? So first one is bromination and the second one is nitration. Then from here, there is another important question, reasoning type question. Although NH, I told you that ortho NH2 is an ortho para directing group, is it? But we get meta-nitroaniline. Why? This is again a reasoning type question. Although NH2 is an ortho para directing group, yet aniline on nitrogen gives a significant amount of meta-nitroaniline. Why? See, aniline on treating with strong acidic medium, I told you that it will react. Aniline is a base and it is as a strong acid. It will react to form salt. You will get anilinium ion. You will get anilinium ion. That anilinium ion is meta-directing. So you get nitro group at the meta position. Is it clear? Okay. Next one is sulfonation. Aniline. Aniline on reacting with sulfuric acid. Aniline on reacting with sulfuric acid. You will get anilinium hydrogen sulfate. That is, it is an acid. Is it sulfuric acid is strong acid? It will react to form NH3 HSO4 HSO4. This on heating with 453 to 473 Kelvin, you will get sulfanilic acid. You will get sulfonylic acid, that is SO3H. So from here, this proton will be transferred to the nitrogen, then you will get NH3 plus NH3 plus SO3 minus. So you can see negative and positive charge on the same compound. So if there is positive and negative charge on the same compound, it is called Zwitter ion. Zwitter, Zwitter ion. Is it clear? Okay, the next one is another important question is that aniline does not undergo Friedel-Crafts reaction. Why? Why aniline does not undergo Friedel-Crafts reaction? See, Friedel-Crafts reaction is carried out in presence of AlCl3. AlCl3, aluminum chloride. This aluminum chloride acts as a Lewis acid and the amine is a Lewis base. Amine is a Lewis base. So again, acid and base react to form salt. So this does not undergo Friedel-Crafts reaction. Okay. Next one is diazonium salt. What is diazonium salt? You are already familiar with diazonium salt. What is diazonium salt? Rn2 plus X minus. Where R stands for the aryl group. X may be Cl minus, Br minus, HSO4 minus, etc. So the nomenclature of diazonium salt is parent hydrocarbon. Parent hydrocarbon, parent hydrocarbon plus diazonium plus name of the anion. So I'll give example for that. What is the IUPAC name of this diazonium salt? C6H5 N2 plus Cl minus. So the parent hydrocarbon is benzene. So it is benzene. This benzene plus diazonium. N2 is the diazonium plus diazonium. Then Cl minus is what? Chloride. So benzene diazonium chloride. Simple, is it? Next one is C6H5 N2 plus Cl minus. So it is benzene. So the same I wrote. HSO4 minus. So it is benzene, 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 then diazonium, hydrogen sulfate. Hydrogen sulfate. So it is easy, is it? The nomenclature of diazonium salt. Okay. The next one is the method of preparation of diazonium salt. Very important. What is that? Primary aromatic amine react with nitric acid to form diazonium salt. That process is called, that reaction is called diazotization. So here, aniline, aniline on reacting with nitrous acid, that is NaNO2 plus HCl at 273 to 278 Kelvin, you will get benzene diazonium chloride plus NaCl plus 2H2O. So this is the method of preparation for diazonia salt. Is it clear? The next one is chemical reaction. Chemical reactions are of two types. Reaction involving the displacement of nitrogen from the benzene diazonium chloride. The N2 will be from that N2 will be eliminated, displaced. The next one is reaction involving the retention of diazo group coupling reaction. So this we already done, that is azodieters. Here azodieters is coupling reaction is discussed, that we already discussed about azodieters. So the first one, reaction involving the displacement of nitrogen. The first one is reaction involving the replacement of nitrogen. The first one by the replacement of halide ion or cyanide ion. See, this is aryl diazonium salt or benzene diazonium salt. This on reacting with cuprous chloride, that is Cu2Cl2 in presence of HCl. You will get chlorobenzene. You will get chlorobenzene. If you are reacting with Cu2Br2 in presence of HBr, you will get bromobenzene. You will get bromobenzene. If you are reacting with CuCN in presence of KCN, you will get cyanobenzene. Cyanobenzene. So this is called Sandme's reaction. Which name reaction is this? Sandme's reaction. Sandme's reaction. Okay. So this is important, that conversion questions, this is very very important that you have to study. Next one is next one is instead of Cu2Cl2, if we are treating with copper powder in presence of halogen acid, you will also the chlorobenzene and bromobenzene. You will obtain chlorobenzene as well as bromobenzene. That is Rn2 plus Cl minus in presence of Cu in presence of copper powder in presence of halogen acid, you will get chlorobenzene. If you are treating with copper powder in presence of HBr, you will get bromobenzene. Bromobenzene. So this reaction is called, these two reactions is called Gattermann reaction. Gattermann reaction. So is it clear? If you are treating with Cu2Cl2 in presence of HCl, you will get chlorobenzene. Instead of that Cu2Cl2, if you are using copper powder also in presence of HCl, you will get chlorobenzene. So in your exam, there will be the question like this: convert benzene diazonium chloride to chlorobenzene. How will you convert that? You can either do Sandme's reaction. What is the question? Convert benzene diazonium chloride to chlorobenzene. That is C6H5 N2 plus Cl minus. On treating with Cu2Cl2 in presence of HCl, you will get C6H5Cl. You will get chlorobenzene. Okay. I hope this is clear for you. The next one, in the same way, we can done the replacement of iodide, fluoride, benzene, OH, NO2. So we can see that Ar plus N2 Cl minus. If you're treating with potassium iodide, if you're treating with potassium iodide, that is Ki, you will get iodobenzene. You will get, what you get? You will get iodobenzene. Okay. If you are reacting with if you are reacting with fluoroboric acid, that is HbF4, fluoroboric acid, you will first get benzene fluoroborate will be obtained, that is N2 plus BFO minus. This on heating, you will get fluoro fluorobenzene. Okay. If you are reacting with hypophosphorus acid, H3PO2, H3PO4 in H2O or C2H5 ethanol, you will get benzene. You will get benzene. Okay. Then, if you are reacting with warm water, if benzene disodium halide is treating with warm water, you will get alcohol. Okay. If aryl disodium chloride is treating with potassium iodide, you will get iodobenzene. If you are reacting with fluoroboric acid, then on heating you will get fluorobenzene. If you are reacting with hypophosphorus acid in the sense of water, or if you are treating with ethanol, you will get benzene. If you are reacting with warm water, you will get alcohol. And there is one more reaction. If you are reacting with Ar into plus Cl minus, if you are reacting with fluoroboric acid, you will get Ar into plus BF4 minus. This on treating with NaNO2, NaNO2 in presence of copper, then on heating you will get nitrobenzene. 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 So this whole reaction is very important for the conversion part. So I hope this is clear for you. First in this section we discuss the chemical reactions. The chemical reactions first discuss about the basic character of amine. Then we discuss about acylation and then dissociation test for amine. Then disodium salt. Then what is disodium salt? What is disodium salt? Primary amine react with nitrous acid to form disodium salt. That reaction is known as diazotization. And we see the chemical reactions of diazonium salt. I hope this is clear for you. If you have any doubt, comment on the comment box. Okay, thank you.